In this video, we're going to talk about modules, and modules are a collection of functions that you can use, and we've already been using modules in this course. As a matter of fact, Turtle is a module. So the one thing that you just haven't seen is that behind the scenes, CodeHS, this website that we use, is using already imported the module for you. It imported all the Turtle commands, and so you can just type in things like forward and have it do forward. We've also used the math module quite a bit and mentioned before that there are different ways of importing. If you just hit import math, then you import all the functions in math, but you have to specify that using the math module. So if I want to use a cosine function in math, I type math.cosine. If I want to use pi, I do math.pi. This is really clean. It makes it really clear that the cosine function is in the math module. And so if you don't have any other reasons to do other things, this is the way that I guess we should lean towards using it this way. If you do things a lot with the math module, you can give it a shortcut. Import math as m, and this way you don't have to type out math. You just type out m.cosine m.pi. You'll see this later. NumPy, for example, just traditionally has been shortened to NP. And if you only have a couple functions that you need, you can just import those functions. And now if I'm importing pi and cosine, I don't need to have math.cosine, math.pi. This is all you need to do to get that. Another common module that we're going to use in this course is random, because we can use it to make interesting games and so forth. By the way, I'm giving you an overview of these modules. You don't have to memorize all the different functions and methods. You can always look these up as you need it, but I want to show you what's possible. A few of these we'll use and probably worth noting, remembering. Random.random, for example, if I'm importing the random module, the random method returns a random number from 0 to 1 inclusive. So it's just going to be some decimal that is random-ish. And by the way, computers cannot do real random numbers. These are pseudo-random numbers. We won't get into that now. Or Gauss will give a random number. Now the first random number will have a uniform distribution. That means any number is going to be equally likely. But Gauss function will return something with a normal distribution. So it'll give you the mean and the standard deviation, or you'll specify the mean and standard deviation. And more of the values will come back close to the mean, and fewer of them will come back farther away from the mean. Random int is one that we'll use a lot. That gives you an integer between 1 and 10 inclusive. Let me run this so we can see what these look like. I mean, you can't really, yeah, okay, that's a random number. Yeah, that's a random number. And then randint gave us a decimal. I'm sorry, an integer. Some of the other things you can do with the random module is if we have, let's say, a list of students in a club or something like that, you can do some sampling. So choice will pull out somebody. Like in this case, it randomly chose Deb. And sample will let you pick 4 things randomly. And it's going to do it with that replacement. So here, it picked 4 people out of a list of 5, and you will never see a duplicate here. The next one, choices, will pick 4, but a replacement. That means, let me run it again. Here it picked B twice because it's not keeping track. It's just every time it's going to pick another random name, so it could be the same person twice. Again, sample will pick 4 without replacement. Choices picks 4 by essentially putting the marble back and picking it again, that type of thing. This is an interesting one. Shuffle will just actually change roster. Roster right now used to be alphabetical, A, B, C, D, E, and you'll see that now it shuffled it. Not very exciting. It just switched the last 2. Run it again, it'll be shuffled again. So this will just actually changes the roster list and shuffles it in place. Another module that is useful is the decimal module. We won't use it that much in this class, but to illustrate it, why it's important, if I take 0.1 and multiply it by 3, you think that's going to be equal to 0.3, right? No, it's not. This is false. And the reason is when I print that result, there's round off, there's error, and called floating point precision error. We see that all the time, and we're just so used to it. Like, for example, if I say what's 2/3, you'll say 0.6666, and would you say 7? Well, that's round off. It's not exactly 0.66666, right? So computers have that a little bit worse because we have a fixed limit of decimal places that it can handle. And so the decimal module will help you by keeping track of, let's say in this case, you can set the precision, 7 decimal places, and it will do things right up to 7 decimal places, so you won't have to worry about round off. Now, again, you don't have to memorize these. You can look these up when you need it, and I just wanted to give you a sense of what's possible out there. Now, collections is another module that's built in. By the way, all of these so far are built-in modules. You don't need to do anything special to have them. They come with all the distributions of Python, so you can just import them. And I just imported one function called the counter function. What that does is it takes data, and it actually counts up how many occurrences of each of the values are there, and it prints it out. So it makes a dictionary and says that there are 4 instances of 10. There's 1, 2, 3, 4. There are 3 instances of 0, and so forth. Pretty handy. We'll actually look at a way you can do that in one line anyway with Python. A really powerful one is itertools. It makes iterators which generate a sequence of numbers that you can loop through, or sequence of items. Range, we've been using range, and that really is an iterator. Range, will go through and it'll give you the numbers 0, 1, 2, 3, 0, 1, 2. Every time you run it, it'll pick a different one. It doesn't actually make a list ahead of time. Just every time you call it, it knows where you left off and pulls out the next number and gives it to you. So this is an iterator, but itertools makes things that can go beyond this. For example, one of the things that itertools has is a way to make an iterator that will cycle through a list. So if you want to do this 10 times, the first time around it's wash, next time around it's rinse, next time around it's repeat, and then it goes back again, wash, rinse, repeat, and it does that 10 times. Now in this way, the way you pull out the next instruction from the list, itertools again, makes an iterator. Here, I know I want to go 10 times because otherwise this iterator won't end. You say next, I want the next instruction, and it's going to go through one at a time and pull out the next one. And by the way, just in case you forget, end equals will print it but not put a carriage return at the end, and it'll just put on the same line with a space in between. So if I run it, you'll see what that is. And wash, rinse, repeat, wash, rinse, repeat. Oh, I skipped these. This one, the toppings, itertools has a way to get combinations and permutations. You can do that as well. So it finds different combinations of toppings 3 at a time. So it'll pull out 3 toppings, sprinkles chocolate nuts, and then it'll pull out sprinkled chocolate Oreos, and it hands it back to you. And in this case, since I have one variable there, it returned a tuple of 3 toppings. These are all the different choices, which is pretty cool. It would take a lot of thinking to figure out how to do this without having the combinations in itertools. The regular expressions module, RE, is powerful, but it's wicked confusing, and you will see it because it does some things which are really powerful, but it's just a bear to get your irregular expressions correct. Here's a text that's a sentence. If we want to pull out all the words from this string, we could try splitting it up, but split really just gives you one character that you can split on. You can split on, let's say, the spaces, but look at all the other punctuation there. What happens if you wanted to try to split this up without dealing with the punctuation? Regular expression can find words, and that's the W keyword is. So this will find all the words in this text, and the rest of this are just codes that you have to just wade through and figure out. Like this B/B will start at the beginning and the end, and there's in the plus. It's you'll have to really work to figure this out. I actually grabbed this from the interwebs, but this if you get it and it works, it's really, really powerful. So it found all the words, ignored all the punctuation, and that was pretty cool. There's a module called DateTime, and it has a library called DateTime, and it has I think it's called, I wouldn't know exactly, but I think it's called a submodule underneath it, and time delta. I imported two things, but this is what it sounds like. It lets you work with dates. So if you want to set a birthday, this makes a birthday as a date object, and you can print the birthday. You can format it to be in a certain, this is ISO format, which is year, month, day. You could pull today's date, and it makes its own date time object, but you can then print it either using ISO format, or you can print it with this string formatted time string. And this way you can just specify that you want this to have the day of the week. In long, you wanted the short abbreviation for month. You wanted the day and the long 4-digit year. And so you get to specify how you want this to look. You can do some date arithmetic, like how old are you? How many days old are you? Well, take today minus your birthday, and you find out you're 5,204 days old. And you could do things like, well, when are you going to be 10,000 days old? And, ooh, do I have a mistake? No, I don't think I have a mistake. It's 2037. So that's when you're going to be 10,000 days old. Okay, the last one I'm going to talk about, well, actually, the second to last one, if you want an Easter egg, try typing this, import this, and see what it does. Okay, that's just a little Easter egg in Python. I'm not going to tell you what it is. I'll ruin the surprise. Okay, NumPy is really powerful. One of the reasons modules are so good is because they speed up your code, as well as having all the debugging and extending Python to make it so much more powerful without you having to write everything from scratch. And one of the reasons they make it that modules can make it faster is modules can be written in C, programming language, which can be a lot faster than a code that you write in Python, because C is compiled. And so NumPy is one of those that's mainly C code that's you now have access to in Python. And NumPy does data processing, and is specifically working with lists, which they call arrays. So if you want to make two arrays, you just essentially take a list and convert it to a NumPy array. There's other ways of doing it, and we can just print those. But look at how powerful this is. If you wanted to term by term multiply these things together, take 10 times 6, 12 times -4, and so forth, that'd be a lot of work. Well, not a lot of work, but it'd take a little program to write. And with just one NumPy statement, you can multiply 10 times 6 and get 60, and then -12 times 4 and get -48. And so you can do a lot of really powerful operations, or take the fast Fourier transform on each module, each item in a NumPy array. You can even do some comparison. This makes a new new array where actually, this is a new array, by the way, that we multiply those things together. This is a new array where we just test, is the value greater than 24? If it is, it puts a true. If it's not, it puts a false. That's why I have lots of falses and trues, depending on how big the values are. But here's where it really shines, is we have a long list that's just a one-dimensional array, just 12 numbers. But if we want to reshape it, we can turn it into a list of lists, which means this is an array that has 3 elements per row and 4 rows. And so this is pretty cool. And likewise, you can still do the same type of powerful manipulation on each one. If you want to multiply every element by, if you want to square every element, then one statement, and you've gone through a list of lists and squared every element. So if you're trying to do something that you think would be kind of a common function in programming, just double check before you write it yourself that there isn't a module that does it for you. Don't reinvent the wheel.